Okay. Can I say it is rate of doing work then?
Yes, sir.
Yes. Right heading. Define power. Define power. The rate of doing work is called as power. Therefore, it is given by P equals to work done upon time, that is same as dw upon dt. Its SI unit is joule per second or watt denoted by W. Its dimension is power dimension. Can you remember?
M1 L2 T minus 3.
करेक्ट. जूल का m1 l1 t2, तो ये इसका m1 l2 t माइनस टू और ये ऊपर गया तो -3. नहीं याद है तो रफ में कर लेना. m1 l2 t minus 3. करेक्ट ना आर्या?
Yes, sir.
अच्छा, I think Pranjali said is m1 l2 t minus 3. Correct. Right till this.
Done, sir.
Done, sir.
And write note. So this chapter work for energy, because it is mathematical, usually they will ask you one MCQ. No. Power का formula I am writing in different form in note. First is power dw by dt, or you can say total work upon total time. Work is nothing but change in kinetic energy upon time. Also, work can be potential energy. upon time. In case of gas or fluid, work done, uh, power equals to, work is nothing but, is it force into displacement work?
Yes, sir.
Okay. If I divide by A and multiply by A, what is area into change in distance? Suppose this is area of base. This is change in distance of the fluid. What is this part called as? Volume, na?
Yes, sir.
Area of base into. So it is P, pressure, into dV upon time. Power equals to P dV, which is work upon time. Okay. P dV equal to work. P is equals to pressure. ये एक special case के लिए याद रखना. Now please write all formulas.
Done, sir.
Done, na? Okay. Now we did work, we did power. Now energy. What is energy?
Capacity to do work.
The capacity to do work is called as energy. What is kinetic energy? Energy possessed by the body due to its motion is called as kinetic energy. Right, two definition. Karna, can I clear it off?
Yes, sir.
Yes, sir.
Okay. Derive expression for kinetic energy. Now you all know half mv square. थोड़ा मैं derive कर देता हूँ. Consider a body of mass m moving with velocity. Consider body of mass m moving with velocity u. Body of mass m moving with velocity v starting from rest. Starting from rest. Let a comma s be the acceleration and displacement. Now since work done equals to force into displacement equals to MAS. So this is M into V square minus 0 square upon 2. Because 2AS is V square minus U square, therefore I wrote this one. By work energy theorem, kinetic energy, change in kinetic energy is work done. Okay. Work done, we got M V square upon 2. Since capacity to do work is called as energy, therefore kinetic energy is mv square by 2. So this is formula for kinetic energy, half mv square. Like this. I did only because in case suppose some college asks for 1 mark, you should not lose that mark.
Done, sir.
Define potential energy. The energy possessed by the body due to its position and configuration, the energy possessed by the body due to its position and configuration is called as potential energy. The energy due to position is also called as gravitational potential energy. Is called as gravitational potential energy. The energy due to configuration is also called as elastic energy or sometimes stored energy due to elasticity. So one is gravitational potential energy, other is energy stored in the spring called as elastic energy. Copy this much.
Answer.
Okay. So elastic potential energy or gravitational potential energy are two types of potential energy. Derive expression for gravitational potential energy. Consider a body of mass m to be moved against gravity by distance by height h. So can you tell what will be gravitational force? Gravitational force will be mg acting downward, against which we are moving it by height h. So work done against the gravity by the body will be gravitational force into height. because work is force into displacement. This work done will get stored in the body in the form of potential energy. So consider a body of mass m to be raised by height h against gravity. Therefore, work done against gravity equal to mgh. That is potential energy equals to mgh. Right. Yes, completed.
Yes, sir.
Okay.
Just a second,
Yes,
sir.
sir.
Okay. This is easy part what we are doing today.
Done, sir.
Okay. Now one of the very important derivation. One is the definition of power, and this derivation is usually asked in the exam. Derive expression for potential energy stored in stretched elastic spring. Consider a spring having force constant K. Suppose this is unstretched string having force constant K. What will be the force acting here? Will there be any force acting? Unstretched?
No.
No. So
No.
force acting will be 0. When you stretch this by distance x, stretched by x, now what will be force acting? First of all, will there be force acting or not?
Yes.
In
Yes,
which
sir.
direction? Left, na? Because it is always restoring force. Spring force is restoring force. Hello?
Yes, sir.
So can I say it will be acting opposite? नहीं समझा रखता है। स्प्रिंग इज पुल्ड राइट, तो फोर्स किधर सोचेगा उसको लेके जाने के लिए, जो स्प्रिंग के अंदर है,
Left side,
Left.
sir.
लेफ्ट में, इसलिए ऑपोजिट दिखाया। इफ आई कॉम्प्रेस इट, नॉट स्ट्रेच बट कॉम्प्रेस बाय एक्स, नाउ वेयर विल बी द फोर्स एक्टिंग?
Right side.
Right side.
So what you see, force only acts when there is some change in the shape of this spring, either by elongation or by contraction, and direction of that force is opposite, and magnitude will be depending, कितना ज्यादा स्ट्रेच किया उतना ज्यादा फोर्स, जितना ज्यादा कॉम्प्रेस किया उतना ज्यादा फोर्स, मतलब डायरेक्टली प्रोपोर्शनल। इतना लिख के 3 डायग्राम बनाओ, फिर मैं डेरिवेशन करता हूं पूरा।
Done, sir.
So I got idea, whenever there is spring, either stretched or compressed, there will be restoring force in ulta direction, and magnitude will be directly proportional to displacement. I hope you all followed this. Yes, you all followed the direction of this restoring
Yes,
force.
sir.
Okay. When spring is stretched by distance x, then restoring force acting in the spring, रिस्टोरिंग मतलब फिर से अपने जगह पे लेके जाने वाला फोर्स, इज गिवन बाय एफ proportional minus x, negative sign indicates that it is directed opposite to the displacement. Therefore, F equal to minus kx. Okay, just copy till this now. Okay, class 10, एक class 10 बोलना आप लोग. This force is variable or constant? Yes, this force is variable or constant?
Constant.
No, x is variable, na?
Yes.
So this force is what? Variable, correct? Na?
Yes, sir.
Okay.
Yes, sir.
Now can you anybody tell me how to get work then? By integration method क्या direct formula?
By integration.
Integration.
ज्यादा सोचने का जरूरत नहीं, वेरिएबल मतलब इंटीग्रेशन फिक्स. ओके, नाउ कॉपी.
Yes, sir. Done.
So we get forces equals to minus kx. We are interested in potential energy. That means indirectly capacity to do work is called energy. So if this is spring, if I pull it by very small distance, very small. So it is assumed that in very small distance, force is remaining constant. Let the spring be pulled by very small distance dx against force F. So very small distance means we have assumed in that distance force is constant. Therefore, work done against force, comma dw is minus force into displacement. Minus because it is force is acting to the left, displacement is to the right, ulta direction is the negative. But force is minus kx. So I get dw equals to plus kx dx. So total work done to stretch the spring from 0 to x, comma w is integration of all small work done from 0 to x. Therefore, w is kx dx from 0 to x. You all please copy till this, then I'm explaining how to solve this integration.
Done, sir.
W equals to k, constant I brought outside, x dx from 0 to x. This is k. What is integration of x?
X square by 2.
X raised to 2 upon 2 from 0 to x. That is k x square by 2 from 0 square upon 2. So this is k x square by 2, which is equals to half kx square. This work done is stored in the form of potential energy. Therefore, P dot E, usually denoted by U, equal to half kx square. So potential energy in spring or elastic potential energy is half kx square. Now, because you can see there is integration, somewhat difficult, to college people will definitely ask this for 3 to 4 marks. Any doubt in theory?
No, sir.
We started with force, which is proportional to minus x, so minus kx, then slightly stretching, small work done, then integration. Please copy. One time you'll practice all whatever I am doing in the class, and then only something extra.
Done, sir.
So half k square is potential energy stored in the elastic spring. Everybody is done?
Yes,
Sir.
sir.
See, we got F is kx in magnitude. That means we have 1, 2, 3 variable. That's why we can have same formula with 2 variable. एक kx में मिल गया half kx square. We can also get in f and k. We can get in fx. So since f equals to kx in magnitude, so therefore you can write x equals to f upon k. So since u is half k x square, we can write half k f by k square, which is half k f square upon k square. 1 k will get cancelled. So half of f square upon k. So formula is also f square by k. Again, f is kx, therefore k is f upon x. So u will be half k x square, that will be half f upon x into x square. So half fx, that means half into force into extension, half kx square, half f square upon k. These are 3 formulas for spring force, spring energy. is to form copy. No need to by heart all. You can convert whenever you require. If by solving the sums याद हो गया तो डायरेक्ट भी कर सकते हैं. मुझे तो याद हो गया half kx square half fx half f square upon k. It's in formula. Write this two different form.
Hello, sir.
Yes.
So can you send the solutions of the page paper?
I have started making it. I will send it.
Okay, sir. Thank you, sir.
Done, sir.
Okay. Now come to MCQ sheet. Till 54 you told I have explained you all.
Sir, till 70.
70, sir.
74?
No, till 70.
Okay, still 70. Okay. Now 71, Aya?
Yes, sir.
72?
और सर मुझे नहीं आया 70।
No, 72.
71, nobody wants na 71.
सर आई वांट
71 you want. Okay. 71. A plank with a box on it is gradually raised as angle of inclination becomes 30 degrees. Box starts to slip 4 meter in 4 seconds. Coefficient of static friction and kinetic friction is how much? So static means when it is at rest. So static friction Fs is mu s into n, and F static is mg sine theta, because it is falling by mg sine theta. So friction will try to prevent it at the point of rest. Hello?
Yes, sir.
Yes, sir.
This is mu s into mg normal reaction. ये mg का component is mg cos theta here. So mg cancel. We can say mu s equals to tan theta, that is tan 30. Tan 30 is 1 by root 3. 1 by root 3 I can write root 3 upon 3. So 1.732 upon 3. 0.35 is a 15.
577.
7. So that is approximately we can write 0.6 at rest. तो जिसको नहीं आया आंसर पहले इतना कॉपी कर लो. 0.6 is static friction. से एक मिला ना, तो सेकेंड वन इज हैज टू बी 0.5 बिकॉज स्टैटिक से छोटा होता है काइनेटिक, बट स्टिल आई एम डिराइविंग.
यस सर.
काइनेटिक वाला देख लेते हैं क्या होगा. It starts moving, covers 4 meter in time 4 second. 4 meter in time 4 second. Initially it was at rest. We want what is coefficient of kinetic friction. So motion is in downward direction. So friction will be again ulta. Net force equals to mass into acceleration. So it is force applied, that is mg sine theta, minus opposition is Fk, should give me ma. Therefore mg sine theta minus mu k into normal reaction mg cos theta equal to ma. Throughout m can be cancelled. This is g sine 30 minus mu k G cos 30 equal to A. That means if I get A, my problem is solved. Since S equals to ut plus half at square from kinematics. So 4 meter distance covered initially at rest 0 plus half a time is 4 square. So therefore 4 equals to half a into 16. 2 8 the 16. So a equals to 4 by 8. Therefore a equals to half. Just copy, then I will clear this, substitute the value.
Yes, sir. Done.
So our formula, we got g sine theta. In that I am substituting all the values. Mu k we want. A we got half, which you can say 0.5. So g is 10, sine 30 half minus mu k we want. G is 10, sine cos 30 is root 3 by 2. This we got half. Throughout 2 you can cancel. Therefore 10 minus 1 is mu k into 10 root 3. So 9 equals to mu k into 10 root 3. Mu k will become 9 upon 10 root 3. That is 0.9 upon root 3. So this will be 0.9 multiply by root 3 and divide by root 3. So नीचे rationalize हो गया 0.3 into 1.732. 17 3s are 51, so close to 0.5 हो गया answer. 0.5 and 0.6, that is option D. Now followed current.
Yes, sir.
72 also you want ना?
Yes,
चलो
sir.
करता हूँ.
Yes, sir. Done.
72. A uniform chain of length L is partly on the table and remaining part hanging down from the edge of the table. So imagine this is one table. We are having this is one chain. Partly it is on the table and partly it is hanging down. This is the chain. This much clear meaning? Partly on the table, partly hanging. Suppose total length is L, total mass is M. If coefficient of friction between chain and the table is 0.5. What is minimum length of chain that should be on the table? Let X be on the table. So how much is hanging?
L minus X.
L minus
L
X.
minus
Minus X is hanging. L minus X is hanging. What minimum length of chain that should be on the table to prevent the chain from slipping? down. 1 minute. Huh? One minute. What is the minimum length of the chain on the table that should be prevented from slipping down to the ground? ये इतने वेट का, इतने वाले का वजन नीचे खींचेगा ना इसको,
Yes, sir.
और इसका फ्रिक्शन इसको ऊपर पकड़ेगा ना ऐसा. So can I say to prevent from slipping down, to prevent from slipping down, frictional force must be equal to weight of hanging chain. Weight means m into g. So if mass per unit length, I take mass of unit length, एक का इतना, तो L minus x का मास इतना होएगा ना, into L minus x. ये लाइन समझा? हेलो?
Yes, sir.
Yes, sir.
This means एक का मास, total mass upon total length, मतलब एक का मास, तो L minus 1 का मास into L minus x into g. वेट समझ गया कैसा निकाला मैंने? अभी फ्रिक्शन मींस म्यू into मास into g. अब ये किसका मास है? जो टेबल पे है, तो ये m by l यूनिट हो गया एक के लिए, तो टेबल पे x है into g. I hope you followed this line. Yes.
Yes, sir.
No, सब
Yes, sir.
समझा नहीं है, झूठा बोल रहे हैं. वैष्णव you
One
followed?
more time, sir. One more time.
हाँ, देखो अभी देखो, आप कभी भी क्या करना, आप टोटल लेंथ का मास m है ना, तो x का कितना, इट विल बी m into x by l, बराबर.
Yes, sir.
तो मैंने सिंपल में क्या किया, पहले एक का मास निकाला, एक का मतलब एक यूनिट का, तो एक यूनिट मतलब टोटल मास अपॉन टोटल लेंथ, तो एक का हो गया ना आंसर. इसको बोलते हैं यूनिट मास, यूनिट लेंथ का मास. ठीक है, नहीं समझ रहा था. हेलो,
Got, sir. Got.
देखो इसके लिए है ना, L का मास m, तो x का कितना, और पहला एक का कितना लेते हैं, एक का कितना, तो एक का कितना 1 into m अपॉन l, m by l एक का हो गया ना, एक मतलब एक यूनिट लेंथ का, तो 2 का into 2, 3 का into 3, 4 का into 4, x का into x, ऐसे.
Got, sir. Got.
Pardon?
Got, sir.
Okay, so mass per unit length is for 1, so mass for x into x, mass for L minus x into L minus x. Who has not followed, please tell us. This is very important concept. इसके ऊपर एक सम आपको दिया था टेस्ट में, फर्स्ट वाला सम. Yes, Vaishnavi, you followed this? Nandini?
Yes, sir.
Yes, sir.
Both currents?
Yes, sir.
Yes, sir.
Okay. Abhi, what we can cancel? G we can cancel, m by l we can cancel, mu is given 0.5 into x equal to L minus x. So this is 1.5x equals to L. X equals to L upon 1.5. That is 10 upon 15L. 5 2s are 5 3s. X equals to 2 by 3L. This is the answer. 2/3 of L must be on the table. Copy full. Very good sum.
Done, sir.
So that's all for today. Please revise and keep everything ready for Friday's work. Till which sum I have told you homework?
110.
110.
That much you have completed? 110 you
Yes,
have
sir.
completed?
Yes,
So
sir.
can you try at least 140 tak aage bhi? On Friday I will discuss all. Please try till 140. Just 30 sums I have given ahead. See, when you practice more, you will understand if your doubts are clear. If I solve all, I will understand, but you will not remember anything. So please solve. Doubts I will clear. I'm giving you the time to solve doubts on it. Extra also I will take, but please attempt once on your own after understanding the concepts. That's all for today. Let us meet on Friday. Test portion you are knowing, I think.